I just wanted to make a really quick video to show you what's expected out of project number 9. So in this project, we're going to use arrays to help us keep track of a very simple game. And we'll also need to be familiar with the generation of random numbers to assist us with this project as well. So that was one of the last things that we had talked about in the notes, how to simulate the roll of a die. Anyways, the tasks for this project are we're going to create a class called Dice Game, which should declare but not instantiate 5 integer type arrays. They should be called p-score, c-score, p-wins, c-wins, and ties. So again, you're going to declare them, but you're not going to instantiate them. You're not going to give them a size. You're not going to ask for memory yet. You'll see why later. Next, your class should have a user-defined constructor which receives a single integer variable, and that's going to become the size for all of the arrays. So when the user is running the main program, they're going to pass in a number that is going to represent the size that all of these arrays should become. So we have to wait to get that number from the user in our constructor, and then we will instantiate all these arrays that we had previously declared. Next, your class should have a method called run. Run's going to set up a loop that's going to generate dice rolls for the player and the computer. The value of each dice roll should be stored in p-score for the player and c-score for the computer score. Also, for each simulated round of the dice rolls, you want to figure out who won or lost. So whoever has the higher dice roll wins. If the player won, I want you to put a 1 into the p-wins array at that particular component. So if this is my first game, remember the first index is 0, and the player wins, we're going to put a 1 in p-wins at index 0. If the computer won the first game, we're going to put a 1 in the c-wins at index 0. And if they happen to tie, then you're going to put a 1 in ties array at index 0. And then the next time through the array, you're going to simulate a dice roll for the player, a dice roll for the computer, and do the same thing, figure out who won or lost. The dice rolls for the player and the computer should be generated by that method that we wrote in our notes the other day. At the end of the run method, print out the values for each round of dice rolls, state the winner of each round, and then determine who was the overall winner by tallying up all the p-wins, all the c-wins, and all the ties and comparing those numbers. Now, last thing you're going to have to do is write a main method, and in that main method, you're going to have to ask the user how many games they want to play. So this requires a J option pane, show input dialog. You're going to have to take the number they type in, you're going to have to parse it into an integer, and that integer is what you're going to use when you call the constructor for this class, because you're going to pass that number in so that our arrays will be the right size for however many games that the user wants to play. And after you finish doing that, then call the run method to actually play the game. So let me show you what this should look like. Here I've got 2 different versions of this game. The first one, Dice Roll 2, is the one that you should be generating. So when I run this, one of the very first things that should happen, I'm running the main method now, you should ask the user, how many games do you want to play? So the user is going to type in an integer here, let's say 7. Now when I hit OK, I'm in the main method, it should take this value that I type in, it should parse it into an integer, and then use it in the constructor to define how many memory locations all of my arrays are going to need. And then right after that, the main method calls the run method, which is then going to play the game. So this is what the output should look like. For each and every game, you should say, for roll number, and this happens to be my first roll, the results are, show me what you rolled, show me what the computer rolled, and tell me who won or lost that round. So you're going to do that for all the rounds. Round 1, I lost. Round 2, I won. Round 3, we tied. 4, I lost. 5, I won. 6, I lost. 7, I lost. Now, afterwards, you have to compute who was the overall winner. So this requires going through the p-wins column and adding them all up. So I won a total of twice. The computer won 4 times, and there was one tie. So because the computer won more times than I did, overall I lost. Now, because this is randomly generated, if I play this again, I should get different results. So if I play 7 games again, this time, you can see that I won 3 times and the computer won 4 times. So again, I lost. I'm not very good at this game. All right, let's try one more. Maybe I can win this time. This time I tied. So I won 3, the computer won 3 with 1 tie. Now, if anybody is interested in extra credit for this project, this is the same game, except, well, I'll show you what it looks like. 7 games. For each game, when you're doing the round, I wanted to make a little graphic to show not just what I rolled as a number, but I wanted to show what the face of the die would look like. So your roll was a 4, so I actually made a dice with 4 little dots. The computer rolled a 1 with 1 little dot. And I did that for each and every one of these rolls, as you can see. So the functionality of the game is the same, except I added this little feature of graphics. Now, I will warn you, if you do want to do this, this is for extra credit. You do not need to do this as part of the main program, but if you just want a little bit of extra credit, the tricky part about this is that you would have to come up with, there's 36 different combinations of what you roll and what the computer roll. I had to make a graphic for each one of those, and then depending on what the situation was, when I rolled a 4 and the computer rolled a 1, I had to call the method for me having a 4 and the computer having a 1, which is a completely different method from when I have a 3 and the computer has a 4, which is a completely different method from all these other options. So, me having a 4 and the computer having a 3 is different than this one where it's 3, 4. So there's literally 36 different combinations of this. And so I had 36 different methods that I could call that would show a combination of dice. So if you want to try that, it's not that hard. It's a lot of copying and pasting, but you would have to create 36 methods for that. All right, good luck. Have fun with Project 9.